Well, good day, students. Welcome to the first lesson of the new year. This is 1.02, solving equations, and we're going to focus on three types of equations. All of these should be a review from Algebra 2, but it's a review we need to do because you're going to be solving these over and over and over. They'll pop up at any time, and you want to be ready for them. The three types are the quadratic equations, the rational equations, and radical equations. And all of these require different algebraic techniques. Okay, so let's write that down. Algebra. All right, this is pre-calculus is essentially an algebraic course, which means you do the algebra. Okay, number two is pre-calculus is a geometry course, which means we want to look at graphs, which are geometric essentially, fundamentally, because it's a picture of what these equations look like. So we basically want to talk about our objective for today using the new Stride format. And I will try and do this every time. I can't guarantee it, but I will do my best. Anyway, for today, I will solve these three major equation types. All right, rational, radical, and quadratic. Okay, and you will learn how to do that today. All right, and be reminded how to do that so that you can what? Apply solving these equation types to different math settings. All right, so what do I mean by that? So that you will learn how to solve these three major equation types so that you can apply solving these types of equations in different math settings. What do I mean by that? Well, for instance, in the second semester, we're going to solve trigonometric equations, but it turns out they're going to be quadratic in form. And so you have to be able to recognize that quadratic form to be able to solve the equation. All right. We're going to be doing inequalities in another lesson or two. And you have to know how to solve these equations to be able to solve those inequalities. All right. You have to be able to recognize which equation is which and to use the correct techniques at the right time. And you will have it when what? You can self-check your solutions. Now, this is a very important thing, I think, and something that maybe you have not done as much as you were supposed to. For instance, in algebra, we are taught how to check our answers using evaluation. So one of the ways we check our answers is we use evaluation, which means we plug our answer into the equation and see if it gives us a true statement. My expectation is you'll be able to use evaluation to solve your equations. Also, quite a bit, I noticed that in Algebra 1 and Algebra 2, you guys have been using Desmos to do a graph check of your solutions. Now, in some cases, you're actually using the graphs to get the solution. And while that's okay, in my class in pre-calculus, it's important that we do the algebra first, and then we confirm with geometry. All right? And that's a graph check. And so notice there is an algebraic way to check whether you can self-check your solutions, and there is a geometric way to self-check your solutions. Now, because you can self-check, when you do quizzes in K-12 learning, and you go through, when you do quizzes and stuff, a very interesting thing happens. Suppose you have a problem and you have multiple choice answers, A, B, C, D. Well, if it's an equation you have to solve, because they have numbers here, all you have to do is evaluate, plug it in to the equation to see which one works as a solution. Or you could graph and you could see which one's a solution. Now, the problem with that is the problem meant for you to do the algebra. It didn't say check which solution is correct. It said solve for the solution. And when you are asked to solve, you are being asked to do algebra. So let's write that down. Solve means do algebra. All right? Now, this is going to matter when you take tests for me or do written assignments for me. If I ask you to solve, I expect you to do algebra. All right? I do not expect you to check for which answer. These are what we call guess and check strategies. Guess and check. However, guess and check strategies are okay, but the thing you need to learn is how to solve. All right? Now, we're going to do both, and we're going to focus on solving these three equation types and then applying the solving of equations to different mathematical problem settings. And you'll know you have it when you can self-check your solutions. In other words, every time you self-check, you're getting a correct answer. And when you're getting an incorrect answer, you will know how to fix it. So by way of introduction, here's our introduction to the lesson today. So let's get started and move to the next situation. So it turns out solving quadratic equations is a big deal in algebra. And there are essentially three ways to do it. So I want you to pause the video and write down the three ways. Do you remember what they are? Okay. If you did that, the three ways to solve a quadratic equation are factoring, complete the square, and the quadratic formula. And so these are the three typical methods we use. Now, sometimes you might get an equation like this: x plus 1 squared equals 5. And what you do is you take the square root of both sides to solve that quadratic. That's actually a subset of completing the square. All right. And so that's something we'll come across every once in a while. But in general, we factor, complete the square, and do the quadratic formula. Now, here's the tricky part. Which one do you do? All right. Well, in my experience, what I do is I always look to see if I can factor quickly. If I can factor quickly, then that means I can get the solutions. All right. A quick example of that would be like x squared plus 7x plus 6 equals 0. All right. Right off the bat, I can see that this is x plus 6 times x plus 1. Why? Because 6 times 1 is 6, and then 6x plus 1x is 7x. And then, of course, the x times the x is the x squared. So I can factor, and then we have product equal to 0 property, which is if a times b equals 0, then a equals 0 or b equals 0 or both. All right. And so we would then set x plus 6 equal to 0 and x plus 1 equal to 0. And then we would solve the linear equation. X equals -6, x equals -1. And so we would have two solutions, which we could then say, there are a couple of ways we could write that. We could say x equals -6, -1, like that. Or we could say x is an element of the set -6, -1. All right. And those are just a couple of ways to write the answer. Now, then you would check your solution. How would you check? You'd plug -1 in for x. This is evaluation. So -1 squared minus 7. So that's 1 minus 7 plus 6 is 0. -1 checks. -6 would be 36 minus 42 plus 6. So 42 minus 42 is 0. So that checks. So both of these answers are correct. And we have factored quickly to solve the equation. All right. Now, the key with factoring in terms of solving an equation is you have to look at the equation and see if it's possible. So for instance, here's a slightly more difficult one. So let's go with 25x squared plus 16 equals 40x. Now, the first thing is, if I'm going to factor, I want to set it equal to 0. So 25x squared minus 40x plus 16 equals 0. Now, what I notice from my factoring rules, those are both perfect squares. And 5x times 4, the square roots, gives me 20x. And if I double that, I get 40x. So that tells me this fits this format. 5x minus 4 times 5x minus 4 equals 0. This is same factor, so I just take 5x minus 4 equals 0, which gives me 5x equals 4, which then gives me x equals 4/5. And then I can plug that back in to check it, or I could draw a graph of this. And so we'll look at the graphs a little bit later. All right. Well, actually, we can do that now. Let's just go ahead and do it now. So let's check this solution and see if 4/5 is correct. Now, the last one here, I evaluated by plugging them in, just kind of doing it in my head. But this is a fraction, so I'd like to check that. So let me see if I can do this now. Yes. So I've got us a browser window here, which is Desmos. And I can go on Desmos and I can type in the original equation. So it was 25x squared plus 16. And then that was equal to 40x. All right. And so looks like I gotta shrink this down. Oh, that looks a little skinny. So let me go and let me change this up a little bit. So, okay. So I need to work with my window here. That's very important. So my x-axis is really big, but as you can see, things are jammed in together there. So I'm gonna make it a little closer. I'm gonna go like the x-axis is -4 to 4. All right. And then as you can see, that gives me a little better look at it. And it's going to cross, it looks like between 30 and 40. So I want to kind of squish this down, which means I want to make the y values a little bigger. So let's go with the y value of 0 to, instead of 50, let's go to 200. And that'll widen it out quite a bit, and I can kind of see it better. Okay? So there we go. There's our solution. We can see that this line is intersecting our graph in one point. And so I'm going to look at that point. I said x was 4/5, so I went, notice this is 0.5 to 1, so 4/5 is 0.8, so 0.6. So let me, so here's 0.6, 0.7, 0.8. So I look for that, right? And then that comes over and gives me a value here, which looks like it's around 32. Now I have all of a sudden frozen my window and made it something I can draw on. But as you can see, 0.8 was the correct value, and it actually checked. Yeah, it gives us 32. So 0.8 is 4/5. So that's how you can use a graph to check as well, as opposed to evaluation. Now, the other thing we could do is we could still use the calculator. So let me fire up Desmos again. All right. And we could do the calculator version of this. Oh, let me get the right calculator. The scientific calculator. There we go, the Desmos scientific calculator. So then what I would do is I do 25 times 4/5. Whoops. And now I got to square that. And then I'm going to add 16. All right. And that gives me 32. So then I take 40 times 4/5, which is what I got. And that is also 32. So I can use my calculator to evaluate my answers as well. And that tells me that I solved this equation by factoring correctly. Okay, let's go to the next slide, more quadratic. So as I said, we're going to do some more quadratics right here. And essentially, after I try factoring, okay, after I try factoring, if it doesn't work or I can't factor it and I can't see it, if that doesn't work, then I immediately go to the quadratic formula. Okay? And if you'll remember, the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And you can find that by completing the square on if ax squared plus bx plus c equals 0, then x will equal this. So the a, b, and c are the coefficients. So you need to know how to do the quadratic formula correctly, and this requires you to be able to simplify fractions and radicals. So you got to be really good at that. So let's do a quick problem. Let's go 2x squared plus 5x plus 3 equals 0. And so we would like to solve this. Now, right away, I can see that, does this one factor? Oh, it does factor. So 2x and x, and then I will do plus 3 and plus 1. So this gives me 3, this gives me 2x squared, and then I get 3x plus 2x, which is 5x. So this one factors. So, and that, notice, I got it. But you might not have been able to see that that one factors. So that's the other thing. You might have a problem, pretty simple, and you don't see the factoring. So if that's the case, then you want to use the quadratic formula. And so I would write a equals 2, b equals 5, and c equals 3. I would write that down, and then I would proceed to solve. X equals the opposite of b, plus or minus the square root of 25, that's b squared, minus 4 times 2 times 3. All right? All over 2a, which is 2 times 2. So I'll simplify that, negative 5 plus or minus the square root of 25 minus 24. And that is then negative 5 plus or minus 1 over 4. So we can write that as negative 5 plus 1 over 4, or negative 5 minus 1 over 4. And if you look, that gives us a negative 4 over 4, which is equal to negative 1, which is what we got by factoring. Or that gives us a negative 6 over 4, which is equal to negative 3 halves, which we also got by factoring. So there's our two solutions. We can evaluate using our calculator or just plugging them in ourselves and calculating it out. Usually with fractions and negative numbers, I like to use my calculator. All right. And with I can use graphics too, but I would probably just check these on a calculator personally. There are better problems for checking graphically, and we'll see that later. All right. Okay. So that's the quadratic formula. That's how it works. So a couple other issues about the quadratic formula that we need to talk about. The next issue is what is called the discriminant. So it turns out in mathematics, it is okay to discriminate. And what I mean by that is you want to notice that things are different in mathematics, because usually it means you have different kinds of numbers, different kinds of situations, and the mathematics tells you that. And so that's why we give it the name discriminant. All right? Because it is a discriminator. It tells us something about the nature of the numbers we're looking at. Okay? And so the discriminant of the quadratic formula is the b squared minus 4ac. It's the part under the square root. And we know again from Algebra 1 and Algebra 2 that under a square root cannot be negative. All right? Under a square root cannot be negative. And so that leads to a 3-situation discriminator. If b squared minus 4ac is greater than 0, okay, which is what happened here. Notice we had 25 minus 24 is 1. 1 is bigger than 0. And so we ended up with 2 real solutions. 2 real solutions. All right? If the b squared minus 4ac was equal to 0, then the square root would have completely disappeared, and we would have had like negative 5 plus 0 or negative 5 minus 0, which are exactly the same number, negative 5. So we would have only had one real solution. All right? And if the b squared minus 4ac was less than 0, then we would have had a negative number under the square root, which makes it imaginary, so we would have had what are called 2 complex solutions. All right? That's the discriminant. So when they want you to find the nature of the solutions, or to just say what kinds of solutions are we going to have, then you can just do the discriminant. You don't have to actually find it. Alrighty? Oh boy, this quadratic section is very long. So one thing that I want to say to you, first of all, is that these videos sometimes get really long and sometimes they're really short. So they can be anywhere from 10 minutes to an hour. And if you're using the video as your learning tool, then you need to make sure that you watch it, all of it, whether it's a long one or a short one, because there are things I'll tell you along the way that are really important. So we're still working on quadratic equations, all right? Still working on those. We have dealt with solving by factoring and solving using the quadratic formula. And so I want to talk about complete the square. All right. If a problem asks me to complete the square, then I need to do it. Okay. However, if a problem just asks me to solve, then I'm going to do factor or quadratic formula. Okay? Because these will get me to the solution much faster than completing the square. Okay? Now, what I'm going to do is I'm going to make a separate video on completing the square. All right? And how you do it. The reason I'm going to do that is this is an important technique, and we're going to use it again when we get to conic sections. It's just something that shows up every once in a while, and you need to be able to use it when it gets there. So I want to have a separate video on completing the square as a technique. And so I'm not going to put it here, but you can watch that video and I'll put it in the lesson. Alrighty? So let's go on to rational functions. So here we are at part 2. We want to solve rational equations. So what's a rational equation? A rational equation is going to be an equation that has fractions in it. Okay? For example, here's an example. 5 over x plus 4 equals 4 plus 3 over x minus 2. Now, how do we solve a rational equation? Do you remember? All right. So, based on what we see here, the idea of a common denominator is our friend. All right. So whenever you see things added or subtracted together, you want to use a common denominator. Now, what we're not going to do is we're not going to try and write all these as fractions with common denominator. But we're going to use the common denominator to do what I like to call clear fractions. All right? Clear fractions. In other words, we're going to use the multiplication property of equality to multiply both sides of this equation by the common denominator. Now, if you look at all the denominators here, you can see that the common denominator is x minus 2 times x plus 4. Okay? So, we're going to multiply everything in the equation by the common denominator. So, essentially, we're going to take x minus 2 times x plus 4 times 5 over x plus 4 equals 4 times x minus 2 times x plus 4 plus 3 times x minus 2 times x plus 4. all right, over, excuse me, x minus 2. Now, what you notice with the fractions is that we have an x plus 4 in the numerator and the denominator. And that then cancels. All right? Then over here in the last fraction, we had an x minus 2 in the numerator and denominator, and they cancel. And that's the beauty of this, because what happens then is we are left with 5 times x minus 2 equals 4 times x minus 2 times x plus 4. This was just over 1, so nothing canceled. Plus 3 times x plus 4. Now, what we can do is we can multiply everything out and then collect like terms like we normally do. So this will be 5x minus 10 equals 4 times, and this will be x squared plus 2x minus 8 plus 3x plus 12. Now, how did I do this in my head? Well, I did the x times the x and the negative 2 times the 4 to get the x squared and the minus 8x. And then I did the negative 2x and the 4 times x and added those together to get 2x. All right, because those are like terms. So I can do that in my head. You can write it out if you want. In either case, it's fine. Now, I still have one more distributive property to do. So 5x minus 10 equals 4x squared plus 8x minus 32 plus 3x plus 12. So now we want to collect like terms. So we're going to add 10 to both sides. All right. Add 10. So that'll give me negative 22. And then I have a plus 12 as well. So that'll give me a negative 10. So minus 10. And then I'm going to subtract 5x from both sides. So why did I move these to both sides? All to the same side, because it's a 4x squared, so I know it's a quadratic, so I want to make it equal to 0 on one side. So I'll subtract 5x from both sides, so that gives me 3x, and then I have a plus 3x, so 3x plus 3x is 6x. And then finally I have a 4x squared plus that. So now, doing all the fraction work leads me to a point where I have a quadratic equation. Hence why we talked about quadratic equations before. Now, when I look at this, I'm not sure if I can factor it right off the bat. Okay, so I'm going to go ahead and use the quadratic formula. So x will equal negative 6, that's the opposite of b, plus or minus the square root of b squared 36 minus 4 times negative 10 divided by 2 times a, or 4. So now I got to simplify that, and that becomes x equals negative 6 plus or minus the square root of 36 plus 160 over 8. And that's x equals negative 6 plus or minus the square root of 196 over 8. And 196 is a perfect square, so this is negative 6 plus or minus 14 over 8, which gives me two answers, 8 over 8 or negative 20 over 8, which simplified to 1, or, and negative 20 over 8 is negative 5 halves when you reduce the fraction. Okay? So those are my two solutions. So it turns out this one did factor because I get rational numbers, which are integers or fractions. I just didn't see how to factor it right off the bat. And that happens, but that's why the quadratic formula solves them all. So I would use it all the time. Now, just so you know, in your assignments, you are required to simplify these all the way. Okay, like this. However, if you got an answer like -6 plus or minus the square root of 3 over 2, then often if this is the answer, they'll want you to put it in decimal form. And they'll tell you how many places to round to. So you want to be adept at using a calculator to write these expressions. And so hopefully we'll have a problem here in a moment that gives us an ugly answer, and we'll get that. So anyway, that's not our answer here, so we'll scribble it out. So anyway, this is our problem, okay? Complete problem, complete solution. The key fact when solving a rational equation, you need to use a common denominator to clear fractions. Notice how by multiplying by the common denominator of the equation, all fractions will always cancel. And that's just normal, all right? Sometimes when you solve, it ends up being a quadratic. If you recognize that, then you can use quadratic formula or factoring to solve it, okay? All righty, let's go to the next slide. Okay, part 3 is solving radical equations. So what's a typical radical equation? Well, a typical radical equation is going to look like this. We're going to do a couple of these. 2 times square root of x minus 1. X equals 2 times the square root of x minus 1. And so, in order to solve a radical equation, we have to get rid of the radical. And so, usually what we want to do is we want to isolate a radical, and then in order to get rid of a radical, all you have to do is square both sides. All right? Now, if it's a cube root, you're going to cube both sides. Okay? And so this is a very typical way to do that. So I'm going to square both sides. Now notice on this side it's 2 times the square root. So I got to square the whole thing, all right? So liberally use parentheses if you need to. And once I do that, I end up with x squared equals 2 squared, which is 4, and then the square root of x minus 1 times the square root of x minus 1, which is just x minus 1. And once again, we can see we ended up with a quadratic, hence why we did those first. So we get x squared equals 4x minus 4. And we'd like to set that equal to 0. So x squared minus 4x plus 4 equals 0. This one I can factor. X minus 2 times x minus 2 is equal to 0. So x minus 2 equals 0. So x equals 2. And then I want to check that answer in the original equation. All right. And so that would be 2 equals 2 times square root of 2 minus 1, which is 2 equals 2 times square root of 1, which is 2 equals 2. Since this is a true statement, it checks. Now notice what I did is I checked by evaluation. Now, you could do this on a calculator as well. You can just say x is 2, and then you can go 2 times square root of 2 minus 1 and see what the calculator gives you. And if the two numbers are the same, then it's a true statement. If they're not the same, it's a false statement, and what you have is what we call an extraneous solution. And so you need to work on checking all your equations. Because if you go back to our objective says in the third part, I know I will have it if I can check my answers, and if I can check my answers algebraically and geometrically. And then you could also graph each side here and see where they intersect. And if that x value is this value, then you've got it. In fact, this one I could actually do really quick graphically. If I wanted to check it graphically, then one side is x, so that's the line y equals x, and then 2 times square root of x minus 1, so that's the square root, moved 1 to the right, okay, but then everything's doubled. So if you go to 2, instead of it being at 1, you're going to double it and it'll be here. So this is using transformations to graph. And so this is a square root and it'll look something like that. And of course I could do these graphs on Desmos, and I can see this is where they intersect at what value? At the value x equals 2. So this is a valid check as well. So I often put a little check symbol like that if I'm checking my solutions. Now, if there were no solution on a graph, then what would happen is the graphs would not touch, all right? And so that would indicate no solution, and that the solution, the answer you got from the equation was extraneous, extra solution caused by the way you do the algebra, all right? Okay, so we have now solved one quadratic, one radical, and one rational equation. So what we need to look at are some of the variations that you might encounter in the assignment. So let's move to the next slide. Here's an equation that is a radical equation variation, all right? What you would get is something like this: the square root of 2x plus 3 minus the square root of x plus 1 equals 1. So you have two radicals in the equation. So what you have to do is you have to move one of the radicals to the other side, all right? And when you do that, you isolate a radical. So square root of 2x plus 3 equals 1 plus the square root of x plus 1. Then you square both sides. When you square the left side, it just has a square root, so you get the square root times itself, so the square root drops off. But on the right side, I have 1 plus the square root of x plus 1. So that's like saying a plus b quantity squared, which we know from Algebra 1 is a squared plus 2ab plus b squared. Because you have a times a and b times b, but then you have a times b and a times b 2 times. So we have to take this pattern and use this Algebra 1 pattern to square both sides here. Now, I'm sure your teachers in Algebra 2 talked about this, and I would expect you to know how to do this before you were in the class, but hopefully this was a good reminder. Anyway, that means I'm going to have a squared. If this is my a and this is my b, a squared is just 1, b squared is x plus 1, But plus 2ab is plus 2 times 1, which is 2, times the square root of x plus 1. So that's what I get right there. Now, that means I have some like terms to collect. So I have 1 plus 1, so I'm going to subtract 2 from both sides. Okay, so that'll give me a 1 over here. And then I have an x, so I'm also going to subtract x from both sides. And that'll give me x plus 1 equals 2 times the square root of x plus 1. Now I can square both sides again because I have the radical isolated. Once I square both sides again, I get, now notice x plus 1, this follows this pattern again, just not a radical. So x squared plus 2x plus 1. So it's x plus 1 times x plus 1. Make sure you do that. All right. The common error is writing x squared plus 1. That's the error. All right, then I take 2 squared, which is 4, and then the square root of x plus 1 squared is just x plus 1, because square root times square root. So this is also a quadratic. So I do the distributive first, and then I subtract 4x from both sides, and I subtract 4 from both sides, and I end up with x squared minus 2x minus 3 equals 0. And once I am there, this one factors, x minus 3 times x plus 1 equals 0. And then by the 0 property, x minus 3 equals 0. And x plus 1 could equal 0. So x equals 3 or x equals negative 1. So now I have two solutions. So now I need to check, okay? And just for fun, we're going to do a Desmos check on this one, okay? Go to the browser, and we'll do a Desmos check. I'm going to shrink it down so I can see the original problem. So the original problem is 1 on the right side, okay? And then it's the square root of 2x plus 3. You got to arrow out of the radical minus the square root of x plus 1. Okay? Now, y equals 1 is a vertical line. So you'll notice it did not get drawn on Desmos. So you have to be able to do that yourself. So let me, I'm going to do that. Whoops. It's not letting me drag. Well, that's a bummer. Let me see if I can get it over here. Oh, there we go. So there's my check. So there's the graph, there's the subtraction, and then x equals 1. I'm going to go ahead and graph that. Or excuse me, y equals 1 is, because it's y equals 1. Now, that's graphics. So let me let me graph those again, and we'll make it a little bigger so we can look at it. And then I'll get rid of it. So square root of 2x plus 3, arrow out, minus square root of x plus 1. And then we'll do y equals 1. There, that drew it in. And now you can see those solutions. There's one right there at x equals -1, and there's one right there at x equals 3. So those were our two solutions. So there are no extraneous solutions in this case. All right? And so we are comfortable that these are the correct solutions. Okay? So that's how you can check with graphing. And so if you were doing this work on a written test and you showed algebraically, then I would expect to see the check that demonstrates that you know what you're doing. So I would expect to see this graph pasted onto your test or snip clipped or something like that. Or I would expect to see you actually plug them into the equation and evaluate it. And so you could do it either way. Both are correct. I am really good at just evaluating in my head. 2 times 3 is 6, plus 3 is 9. So that's square root of 9, which is 3, minus the square root of 4, which is 2. 3 minus 2 is 1, so it checks. -1, I get square root of 1 minus the square root of 0. So 1 minus 0 is 1, so it checks. So I got really good checking things in my head, doing the arithmetic. And I recommend evaluation highly as an algebraic method of checking. But I also recommend graphical methods of checking. And you need to know how to do both. Both methods of checking are valuable and will really help you. So this is the radical variation where you have two radicals. So there is another variation of radicals, and that would be the case where you might have other powers. Okay, so you might have something like the cube root of 2x plus 1 equals -1. Or they could write it as 2x plus 1 to the 1/3 power equals -1. So you could see both formats. In this case, it doesn't matter which one they give you, you're going to cube both sides. Not square, but cube. And so when you cube it, you just get the 2x plus 1. And on the other side, you get -1 times -1 times -1, which is -1. And so this is linear. So you get 2x equals -2. So x equals -1. And then you check it. So the cube root of 2 times -1 plus 1 is equal to the cube root of -1, which is -1. So it checks. All right. That's what I have on the other side. So I have algebraically checked it. Now I finish the problem. I now know I did it correctly. Okay? So you will know you have it when you can check. All right? If you just assume you're right, then you could be wrong. You could miss extraneous solutions. So for all equations that we do, you must check. Quadratic, everything. All right? Don't let the computer check for you. You check for you. You figure out if you're doing it right. So when you do the practice, before you take the quiz, you know you're going to know how to do it. Now, there is one other variation. So we'll put this up here. Another variation. These are radicals. So what would be another variation, say on, rational variation. A quadratic, some kind of quadratic variation. Let me see here. Let me see if I can find something. Looking. Okay, so here's a good one. You get x times 1 minus x equals 6. Now, you might think that looks like a fairly simple problem. So you do the distributive, and you get x minus x squared equals 6. And you go, wait, that's quadratic, so let me set it equal to 0. So I'll add x squared, subtract x, plus 6. Now, this looks like you could factor because 6 is 3 and 2, but it's a positive 6, so it's plus 3 plus 2, or a plus 5x, or minus 3 minus 2, or a minus 5x. So you're not going to be able to factor it. Whoops, sorry, my video stopped there. So this turns out to be a quadratic that doesn't factor, so I'm going to the quadratic formula using this a, b, and c. And when I do that, I get x equals the opposite of b, which is 1, plus or minus the square root of b squared 1 minus 4 times a times c over 2 times a. So when you do this, notice you get 1 plus or minus the square root of 1 minus 24 over 2 times a, 2 times 1 over 2. But 1 minus 24 is a negative 23. So this is 1 plus or minus the square root of negative 23 over 2. So this is a complex number. So our solutions are 1 plus I times the square root of 23 over 2, and 1 minus I times the square root of 23 over 2. If you remember how to write complex numbers, all right, I is square root of negative 1, so you can pull that out, and this would be the correct way to write your solution. So you could have quadratic equations where your discriminant is negative, and that will then lead towards complex solutions, not real solutions. So these are the kinds of variations that you're going to see. This is solving the equations. Now, there are some minor problem types that use these techniques or parts of these techniques. Let's talk about minor problem types. This really happens on the quadratics. Sometimes they'll say, how many and what type of solution? How many and what type of solution? Well, all you have to do is, if you had your quadratic equation, say 0 equals x squared plus 5x minus 4, like this, then you could say, okay, a equals 1, b equals 5, and c equals negative 4. Let's change this up. Let's make this negative 2 for the a. Let's get a couple extra negatives in there. And then all you would have to do is check the discriminant. So b squared is 25 minus 4 times a times c. All right. So in this case, you have 3 negatives. So, and that's 16 times 2, which is 32. So it's minus 32. So you get the square root of 25 minus 32, which is square root of negative 7. So the discriminant is equal to a negative number, and so negative 7 is less than 0, which means 2 complex solutions. All right. If it was equal to 0, that means you have one real solution. And if it's any number bigger than 0, then that means you have 2 real solutions. And that's it. So that's a minor problem type you'll encounter. Now, I am going to make a video for completing the square, which I will put in the extra things. But my recommendation is when they ask you to solve quadratics, look for factoring or look for the quadratic formula. However, if they and that's even if they ask you to complete the square to solve it, because it's just a waste of your time to do it that way. However, I do want you to watch the extra video on completing the square. And I think I'm going to post those in the content under a thing called extra videos, because completing the square is a very common technique that we have to use. Okay, that's all I have for you. This video is a wrap. Good luck. Work on your practice. I'm sorry for the length of this one. This is really 2.5 chapters in Algebra 2, by the way. So this is just our first section in pre-calculus. See you later.